This lesson will focus on the Class B multi-engine performance requirements for the landing stage of flight. There are two main regulation requirements. The first requirement is that the landing distance must not exceed the landing distance available. In other words, the aeroplane must be able to land within the length of the runway. This requirement can be called the landing distance requirement. The second requirement is that should the aeroplane be unable to land, it must be able to climb away from the aerodrome with an adequate climb gradient. This latter requirement can be called the landing climb requirement. As with other regulations we have dealt with in this course, the requirements relevant to the landing of multi-engine Class B aeroplanes can be found in CAP 698. However, caution must be exercised since CAP 698 contains very abbreviated versions of the requirements and therefore may be misleading. CAP 698 is, after all, only supposed to contain supplementary information for examination purposes only. Let's discuss the landing climb requirements first. If, for whatever reason, a landing was not possible, then the aeroplane should have a level of performance that would enable it to climb safely away from the airfield. This must be possible with either both engines operating or one engine inoperative. The landing climb requirements originate from the certification specifications in CS23, but are adopted in brief format into JAROPS 1. JAROPS 1 divides the landing climb requirements into all engines operating and one engine inoperative. With all engines operating, the steady gradient of climb must be at least 2.5%, assuming these conditions. Notice that in order to demonstrate this climb capability for certification and for operational purposes, the undercarriage is assumed to be extended and the wing flaps in the landing position. However, with the critical engine inoperative, the gradient of climb must not be less than 0.75% at an altitude of 1,500 feet above the landing surface, assuming these conditions. Notice this time that in order to demonstrate the climb capability for certification and for operational purposes, the undercarriage and wing flaps are assumed to be retracted. The reason that the critical engine inoperative gradient requirement is much less than the all-engine climb gradient requirement, and that the aeroplane configuration is cleaner, is because the failure of the critical engine results in an approximate 75% loss of climb gradient. Setting too high a level of regulation would impede on the operational capability of the aeroplane in terms of its payload, because if the aeroplane is unable to obtain these gradients, then the weight of the aeroplane must be reduced to an amount which can allow the gradient requirements to be met. The term used to describe the maximum mass that can be carried and still attain the minimum gradient is called the landing climb limit mass. We did mention earlier that the CAP manual shows the climb requirements. On page 17 of section 3 is the all-engine climb gradient requirement, which, in CAP 698, is called the bulked landing requirement. This repeats that the gradient of climb must be at least 2.5%, and that this gradient must be achieved with these conditions. On the following page is the one-engine climb requirement, this time called the missed approach requirement. Remember that the minimum acceptable gradient must not be less than 0.75% at 1,500 feet above the aerodrome. Thankfully then, these landing climb gradient requirements need not be committed to memory. However, caution must be exercised. The climb gradient requirements mentioned here are specific to aeroplanes in the normal, utility, and aerobatic category of more than 2,722 kilograms, and therefore only represent a portion of the requirements for the multi-engine Class B aeroplanes. Having discussed the landing climb requirements, let us now turn to the landing distance requirements. In fact, these requirements are identical to the Class B single-engine aeroplane. JAROPS 1 states that an operator must ensure that the landing mass of the aeroplane, for the estimated time of arrival, allows a full-stop landing from 50 foot above the threshold to within 70% of the landing distance available at the destination aerodrome and at any alternate aerodrome. This means that the aeroplane must be able to land within 70% of the landing distance available. To help clarify this, let us work through an example. If the landing distance available at a destination airfield is 2,800 feet long, then obviously the aeroplane must be able to land within 70% of 2,800 feet. To calculate this value, we must divide 2,800 feet by a factor of 1.43. Carrying out this simple calculation gives us an answer of 1,958 feet. 1,958 feet is 70% of 2,800 feet. Therefore, the aeroplane must be able to achieve a full-stop landing within 1,958 feet. There is another way to look at the landing requirement. If the landing distance of the aeroplane is calculated to be 1,400 feet, what is the minimum length of landing distance available which will allow a pilot to comply with the 70% rule? In this case, we simply multiply 1,400 feet by 1.43. This gives us an answer of 2,002 feet. Therefore, the landing distance available must be at least 2,002 feet long. If the destination aerodrome has a runway with a landing distance available in excess of 2,002 feet, the aeroplane will be able to land within 70% of the landing distance available, and therefore satisfy the regulation requirement. The 70% landing regulation helps us to see the difference between net and gross performance. Here the gross performance is 1,400 feet, but the net performance, which is always worse than the gross performance and is the 1 in a million worst-case scenario, is 2,002 feet. The landing regulation we have just been discussing can be found in Cap 698, midway down page 17 of Section 3. The regulation states that the landing distance, from a screen height of 50 feet, must not exceed 70% of the landing distance available. If the aeroplane cannot come to a full stop within this length, then the landing distance must be reduced either by selecting a higher flap setting or simply by reducing the mass of the aeroplane.